Okay, we are recording now. Then I proceed to sharing my screen. Okay, then I go to slideshow. All right, so welcome to class once again. It's second week of facilitation. And just as I said in the messages I sent to you, in this class, we'll be looking at units 3 to 5 of module 1. Remember last week we had discussed units 1 and 2 of module 1. So today we'll discuss units 3 to 5, and by the end of this module, by the end of this class, we would have concluded units module 1. We would have concluded discussion on module 1. So as I said earlier, I'd asked you to read units 3 to 5. And so I would like you to send me in the chat box the ideas you read in those units. Just quickly, so that we'll be able to move. You can see it projected, each of the modules. We have basic scientific theories, laws of nature, and history of Western science, origin of it. So I suppose you've read it. Just put in the chat box some of the ideas that struck you while reading. I'm waiting. Nobody is saying anything. Does that mean everybody did not read it? And you don't have idea about what is being said? You know, this class is facilitation. It is not teaching. So you would gain better if you read ahead and you join in the discussion, because it's not everything in your course material that we can discuss in class. Facilitation is meant to be a guide so that it softens the ground for you to understand better and retain more what you've read. Okay, Stephen Gabriel. Okay, he has posted something. Thank you. And being in class is not a time to be checking your course materials. It's a time for you to look at the screen and listen. The audiovisual mode helps you to retain a lot better and to understand. So you don't begin to read your course material while in class. So I will jump right into the discussion. Joseph Abraham, okay? All right. So most of you did not read ahead as said. It's reflecting in your responses. And that's not good enough because you won't get the most from this class. That's what it means. You won't get the most from this class. I tried to send you all reminders this morning, but network was really poor. So don't be surprised if after this class, you start receiving messages about reminder regarding the class. I think I sent it up to 4 times. So if it eventually goes, you might actually receive up to 4 messages about a class that had ended. Okay. So I'll go ahead into the class now. And we take it up from there. My slide is not moving, and I don't know why. Okay. So the first is scientific theory. And just as you have on the screen, it's an explanation. Scientific theory explains the cause or causes of a broad range of related phenomena. So phenomena that seem similar to one another. Scientific theory tries to give an explanation about what causes it, about the cause or the causes of a broad range of related phenomena. So a theory, what it does basically is to explain how things are related or how they have common properties, common features or characteristics. So scientific research with the use of scientific methods leads to the accumulation of facts about nature. Scientific research that makes use of scientific method. Last week, we examined the processes found under scientific method. So when you conduct scientific research using the method of science, it leads to the accumulation of facts about nature. So theories, when we talk about theories, what do we mean by them? Theories, they start with hypotheses. We saw it last week. Hypothesis, what hypothesis is smart guess, also known as tentative formulations, which is meant to explain the phenomena under investigation. So when a hypothesis is confirmed through experimentation, it becomes a theory. This we had explained last week. So you don't just stop at guess, you experiment to confirm that which you have guessed, and then having done that, it becomes a theory. So this just repeats an aspect of what we had discussed last week. So theories, they take different forms. They come in different shapes and sizes, if you like, different forms. It could be diagram, equations, statistical, and propositional formulations. So this schema showing arrow tells you the progression from hypothesis. When you have an hypothesis, you move on to experimentation and then to theory. So it's just an explanation of all the first three bullets that we have on the screen. So theories that have been proven to be valid universally and have a high degree of probability, they are called natural laws. So you could say natural laws emanate from theories that have been proven to be valid universally, maybe the world over or maybe globally, and which have a high degree of probability. That's what we refer to as natural laws. So what does theories do? Theories enable us to explain, to predict, and to control phenomena. Explanation, prediction, and controlling of phenomena. That's what theories help us to do. So when we talk about scientific theories, there are different types of scientific theories. And that's what you have projected on the screen. Universal gravitation, selection by natural means, atomic, genetic, relativity, quantum theory, okay? Those are types of scientific theories. Now, when we talk about precursors of Darwin, Charles Darwin, these are the main precursors of Darwin. By precursors, we mean those who came before him. You know, Darwin is known for his theory of evolution. And so the theory of evolution put forward by Darwin wasn't something that he jumped at. There were persons who had toyed with the idea that eventually Darwin came to articulate and made it much more significant. So that's why we have those who came before him as precursors. You can see their names on the screen. James Hutton, who was a geologist, George Lecomte de Buffon, who was a biologist, and Jean-Baptiste de Lamarck. So when we talk about Charles Darwin's theories of evolution, what exactly are we talking about? So first, we should know that his greatest contribution was that he laid the foundation of an evolutionary theory. He laid the foundation. That's his greatest contribution. Because after his theory of evolution, it didn't end there. There were still some persons who came and commented on it, but he made a significant leap in laying the foundation for it. And so Darwin observed that species, they usually change over time. They evolve, they are dynamic, they are not static. So they change over time, and the environment is one of the factors that bring about the change. So based on the environment a species is found or found itself, it changes. Okay, so Darwin had made such observation. And if you remember, as part of the scientific method, the steps, observation is one of them. So at the heart of the theory of evolution is the concept of natural selection, which is the mechanism that results in evolution. Natural selection is very central to the theory of evolution. That's what we're saying. So Darwin's theory of evolution, it unifies themes in the biological sciences. It brought it about, it articulates it, it brings it together. So it provides an explanation for three main sets of facts about life on Earth. The first one, the first explanation it gave is the display of different types of living things we see about us, the different degree of likeness among living things, this likeness which could be anatomical, that is found in their anatomy or found in their molecules. While the third, the last but not the least, is that the fossil record, which shows a sequence of gradation in the kinds of organisms that have lived on Earth over billions of years. So what this slide is explaining basically is that Darwin's theory of evolution, it unites or unifies themes, certain core ideas or topics in the biological sciences. So beyond just unifying them, it provides explanation for three main sets of facts about life on Earth. And those three are what we just discussed. So when we talk about laws of nature, what are they? Laws of nature or natural law. So for short, natural laws. But another name for laws of nature is natural laws. So the reason why we call them natural law is because they are derived from natural properties of objects and phenomena. The reason we call them that is because of their derivation. We get them from natural properties of objects and phenomena. The uniformities which exist among natural laws. So that's another reason why they are so called. Natural laws or laws of nature also pertain to the consistencies or the regularities which exist among natural phenomena. So the ideas that laws of nature has to do with, the first one, the uniformities found in nature, that is, in behavior, in function, in relations, and properties. Uniformities, resemblances, okay, found in nature that border on the behavior, the function, the relations, and properties of things. The second one is established connection of successive events which make up the order of the universe. Established connection of successive events. We know that by the time we have raining season, we have dry season and the likes. So those are connections, successive, they recall events which make up the order of universe. Those are some ideas, a couple of ideas that have to do with ideas. This thing is blocking my view. So I'm trying to adjust it. Should put it like this. Sorry, that thing was blocking me from seeing well. Okay, so we're talking about laws of nature, what it has to do with these three ideas. Then the third one, established theories through scientific research. You know, earlier we had said Scientific research depends on scientific methods. So having gone through those methods we discussed last week, we arrive at theories. And we don't just arrive at theories in a vacuum. We go through first hypothesis, followed by experimentation before we arrive at formulation of theories. So examples of laws of nature or natural law are law of uniformity is one of the examples. We'll have 4 of them. I will discuss 2. So you may want to ask, what are some examples of laws of nature? Law of causation is another one. Law of gravitation is another one. And law of natural selection is another one. So those 2 highlighted in green are the ones we're going to examine in this class. Okay, so I suppose that you've read the other 2 not highlighted in your private study, which you were asked to. So when we talk about law of uniformity of nature, what does that mean? What this means is that nature is a system composed of several parts, many parts. And despite these different parts that we can find in nature or in the system, everything happens according to rule. Law of uniformity of nature. It claims that nature is composed or comprises of different parts, of many parts. So within this system of nature, everything happens according to rule. So the next explanation of the laws of uniformity of nature is that the law assumes that the universe does not change, and therefore the laws of uniformity of nature governing its behavior remains constant. So there's an assumption behind the law of uniformity of nature, and that assumption is that universe doesn't change. And because universe doesn't change, the law of nature that governs its behavior, it remains constant. It remains like the same over time. So the second type of law is law of gravity, which we are probably familiar with a lot more. So gravitation, which is the force which pulls every object in the universe towards every other object in the universe. That's describing or defining gravitation to begin with. Gravitation refers to that which pulls every object in the universe together towards every other object in the universe. Like if you have a magnet and you have metallic stuffs around you, it's probably going to pull them together to itself, that's to the magnet. Okay, so you can imagine law of gravity as something like that. That is the force, it's a force which pulls every object in the universe towards every other object in the universe. So it's the force that makes a body fall through space towards the earth. Like when you throw something up, the force that makes it come about, such as this, that's what he's referring to. It is the force that makes a body fall through space towards the earth. So the process of this cord falling is what is kind of describing. And the cord has a magnet. So when I do like this, it's able to hold it to some extent. Okay, so this is the kind of thing it's talking about. So the third explanation, it was preceded by Isaac Newton's law of universal gravitation. So that's about different types of laws. These are the types of laws. We explained 2 of them, law of uniformity and law of gravitation. So the next discussion we are going to is origin of science. Have you ever wondered how science came about? So this origin is often traced to Egyptians and the Babylonians. So as a field, science is a breakaway from philosophy because philosophy being referred to as the queen of sciences and mother of all disciplines. Okay. Every discipline used to be one single discipline called philosophy, and science is one of those disciplines that broke away from philosophy. So Egypt is usually credited with the origin of astronomy, and mathematics. That's Egypt in Africa. So they were reputed to be highly skilled in medicine. And the first physician of the ancient world and most famous was the Black Egyptian called Imhotep, who was also referred to as, excuse me, the god of medicine. And beyond this origin of science that we just talked about, we also have an African origin of philosophy that is in the literature. Okay, so but I think that goes a bit beyond our scope. But for those who are interested, philosophy usually is said to originate in the Western world, but there is also an African origin of philosophy. So when we talk about the pre-Socratics, who are they? That's pre-Socrates, those that came, philosophers who came before the era of Socrates. One of them, they are majorly three in number, okay? You have Thales, Anaximander, Anaximenes, and a few others, which we're going to see just briefly. So Thales, father of Western philosophy, water was the source of all things in the universe. So Thales also forecast the eclipse of 585 BC. Remember what we're discussing is origin of science. And we've looked at what scientific methods are. We've examined the different processes of it, the different steps in the scientific method. So Thales and we said that science broke away from philosophy. So many philosophers of ancient past, some of them we refer to as scientists now, were actually philosophers, okay, natural philosophy. So Thales, as one of them, who was also a pre-Socratic, that is, he came before the period of Socrates, is referred to as the father of Western philosophy. And using observation, which later became one of the steps in scientific method, he was able to realize in his environment lots of water, and that made him to say that water was the source of all things. Imagine that Thales came from a riverine area that is surrounded by water. So when he looks around, what he sees is water, and that's what is responsible for his postulation, that water was the source of all things. Thales too also is credited to have forecast the eclipse of 585 BC. Now we would say forecasting is the work of scientists, but these people were philosophers at the time, and they made use of scientific method. At least observation is one of them. So through observation, he was able to observe, to realize what is in his environment and make his postulation. So the next person is, so the pre-Socratics, they are referred to as precursors of science. They were referred to as scientists, okay? And so that's why we trace the origin of science back to them. So Anaximander is another pre-Socratic philosopher who initiated the critical tradition by disagreeing with Thales. So Anaximander didn't agree with Thales, his precursor, sheepishly. So instead of, some of us, when we see that somebody had chosen A, we begin to choose A. Anaximander wasn't like that. So he disagreed with Thales and said, no, that which the world is made of is called stuff or infinite something. In some literature, they call it a peiron, A-P-E-I-R-O-N. So the act of him not following sheepishly what had been said before him. So because of that, Anaximander is credited as initiating the critical tradition by disagreeing with Thales. So beyond that, he was also the first among the Greeks to represent the Earth on a map. So the science of map that we know as cartography now dates back to this period in history, Anaximander, that he was the first among the Greeks to represent the Earth on a map. Despite that, the science of map was known in Egypt and Babylonia long before then, but among the Greeks, he was the first. So the next person is Pythagoras. And we all did mathematics at some point in time. maybe in secondary school or something. And we're all probably familiar with the theory, Pythagorean's theory. So Pythagoras which is a theory in mathematics. The theory itself was named after Pythagoras, who was a philosopher, or who is a philosopher in the pre-Socratic era. So the next philosopher which you have on the screen is Heraclitus, known as a philosopher of change. Now, these days or some years back, we were, as Nigerians, screaming change, change, change. Now we have seen change. But there is a philosopher called philosopher of change because of his postulation. Heraclitus is the person. Heraclitus argued that we cannot step into the same river twice because the water is constantly flowing. That's why he's credited as the philosopher of change based on his postulations. Then the next one is Democritus and Lysippus. They're credited as coming up with the theory of atom. In fact, we refer to them as atomists, yet they were philosophers. Philosophers before the era of Socrates too, especially. So when we talk about Socratics, we talk about Socrates, Plato, Aristotle. Okay. So that's okay. So we will have some time for discussion. That's how the class had been planned. And so all that we have discussed so far, we have them on the screen. We start by explaining what scientific theory is. We looked at definition and types, the different types of scientific theory. Then we moved on to Darwin's evolutionary theory, especially his theory of natural selection. Then we examined laws of nature. What are the different laws of nature? That's examples. Then the definition. Part of the 4 examples we gave, we explained law of gravity and law of, and the other one, I can't remember now. Law of gravity and law of something. Then we moved on to examining origin of science, philosophy, Egypt, Babylonia, pre-Socratics, and the Socratic era. These are what we have discussed so far in the class. So it's time to hear you, to have you contribute, because it's facilitation. It's not meant to be it's meant to be participatory and dialogical. So I'll give you time to make comments, to ask questions, to seek clarification on whichever aspects of the class or of this interaction that is not clear. So I'm going to stop sharing my screen now. Okay, so if you have questions, please put on your hands. Okay, I'm calling Obi Nwabweze Edwin. Unmute yourself and speak. And please make your comments brief, so that please raise your electronic hands. Don't raise your physical hands, raise your electronic hands. Obi Nwabweze, you have the floor. Make your comments or questions brief so that we can take as many as possible. So please go ahead.
Yeah, good afternoon, Matt. Thank you for the presentation. I think this is one of the best class I've enjoyed. The facilitation has been very smooth. But one of the things I observed that in the TMA, the questions in the TMA, they cut across the entire course.
Yes.
So the TMA 1, you are having a course that is, a unit that is still far ahead. Is that the way? I thought it's supposed to be the units that we have covered.
Well, I don't know what the questions you were given are. but
One of the
I
question was talking about the earth. I mean the square kilometer of the earth of Nigeria. I don't know. I
okay.
was wondering.
I wouldn't know the questions you were given, but the way to go is to study you can't say you don't have materials. Some don't even surface for facilitation at all. So the best thing to do is try as much as possible. You can also skim the materials, skim for cogent parts and all. So I may not be able to comment very well on that. I set questions across the course material, that questions that cut across the course material. But how they are going to give you the questions, I don't have control over it. It's done by our Directorate of Exams and Assessments. So the questions you have seen in your TME, I don't even know them. I don't know if you understand.
Yeah, I understand.
So they probably shuffle the question and send. I won't know. I don't know the questions. I didn't see them. Okay. So, but what I would advise is try and skim your course materials to begin with. Skim is fast reading. So you're familiar. I mean, it won't be totally strange to you. You fast read. Then when you come for facilitation, just as we normally encourage, it helps you you both see, you both hear, you have skimmed. You can bet it that you will understand more or gain more. And some too, based on context, you can also answer some questions.
Okay,
I don't know
thank
if
you.
that helps. All right, thank you.
Thank you.
Please lower your hand. So I'll go to call Solomon. Solomon, unmute yourself. Solomon Gua. I can't pronounce your other name. Okay, please, you have the floor.
Good afternoon, ma'am.
Good afternoon, sir.
Yeah, please, I have a question about the evolution, the theory of evolution, particularly theory of Charles Darwin.
Darwin, all right.
Okay, according to the explanation in the course material, or from your explanation, is when the theory is being proven. That is from after it has gone through the process of hypothesis, the test and all that, the theory is now accepted as being true. So in our days now, how was this theory of was this Charles Darwin theory being proven to be true? Or why is it that in our days now we cannot trace or test to know how true this theory was? Like, if you've gone through his theory, how life started and all that, how organism, came came into existence. Was this theory proven to be true? Because from the studies, I'm kind of confused. Yeah.
It's a theory on its own, eh? For the fact that it's a theory, it means that it has gone through experimentation and they think it's true. That's why we call it a theory. So it's not something that somebody just woke up with and said, okay, I'm going to say this, and it becomes a theory. It has passed through some level of rigor. That's why it could be called a theory. So maybe the question you want to ask is, okay, go on.
Okay, okay. The question is, why is it that in our days now, like, a lot of organisms, they have not changed to another form. This is like in our days, this is more than 100 years now. Organisms have not changed into
such as
what
organism? What organism in particular?
Like even like human being, from his own theory, you can see ape, like we human being, we came from ape from his own theory. But in our days now, there is no way you even there has never been a day where somebody experienced an ape, changing into human being.
Let me come in, Solomon. If you have, earlier when the person who asked the question and I was saying, skim your course material. If you skim your course material, you will see that there is a unit somewhere there that has more explanation on Darwin's evolutionary theory, and even puts a picture in your course material of how we humans, we evolved to be what we are now. And also talks about evolution theory as a theory that explains how we humans come about. You know, we have a theory of how the world came about from the Bible.
Yeah.
Excuse me, I need to plug my system. Okay. So, you know, we have that. Some people think, no, we did not evolve from apes, as Darwin tells us. Some people say it is through the Big Bang theory. Some people go with the Bible account of origin of humans. You have that in your course material, and we're going to see that in the course of the class. So what you're saying is not exactly the case, because Darwin's evolutionary theory is premised on that gradation of how we evolve as humans from apes up to where we are now. So it's not so much about organisms don't change, people change, even from mere ants. I think they change to butterfly, to caterpillars and the likes. But Darwin's evolutionary theory precisely talks about human evolution, that our ancestors, your ancestor, my ancestors, we evolved from apes and monkeys, if you like. Okay. But in the course of the facilitation, I'm sure we're going to touch on that. So you may just do some good by looking through your course material to see what it has to say to begin with, before we get there in this 8th week of class facilitation. Is that okay?
Okay.
All right, thank you. Please lower your hands. I'm calling Onu and Uchechukwu. Unmute yourself, please. Is she there or is he there? Anne. I'm calling De France. Oh, you see, some of you, I won't call you. Because last week I asked you, please name your device. Somebody is having user. I'm not calling you. Adeyemi Boluwatife. Unmute yourself, please. Boluwatife.
Yes, good afternoon.
Good afternoon.
Thanks for the teaching, ma'am.
Thank you too.
Ma, you said we have 3 types of theories, right?
No, there are 4 that was projected.
Ma, I didn't get it right. That types of theories.
They are in your course material.
Okay, ma.
Check it. They are there.
Okay,
So
ma.
you don't. But the 2 we discussed too. I projected 4. Theory of gravitation, of natural selection, of uniformity. So you could get them better in your material. And I'm going to, just as we normally do, I would post the link to this class on e-learn. So at your leisure, you could look through it again. Is that okay?
Yes, ma. Thank you so much, ma.
Thank you, sir. I'm calling Ifoma Dio. Ifoma, unmute yourself.
Yes, ma'am.
Good afternoon.
Sorry, I want to ask you something regarding the TMA.
All right.
Okay, I tried doing your TMA yesterday, but the questions haven't been uploaded yet.
Okay.
So I don't.
You don't know what? Anyway, maybe it's from your end. Somebody had commented on how the TMA questions were in the course of this class. So maybe you keep checking, or you seek assistance from your study center why your TMA is not showing yet. But persons have attempted the TMA based on feedbacks I've gotten from this class. Is that okay? And if you are on the WhatsApp platform, you could interact with colleagues and find out if there are other persons experiencing such challenge. But people have done their TMAs in this class. Is that okay? Is that okay? So I'm calling Alima. Unmute yourself. Alima, please unmute yourself. You have the floor.
Okay, good afternoon. Can you hear me?
Yes, I can hear you loud and clear.
Okay, yeah, I wanted to contribute to the person who was asking for the TMA. So I think, I don't know if anyone knows what an open book exam and open test is. That's what it is, where you are able to open your textbook and skim through to be able to answer the question. So yeah, basically that's what I wanted to just add to.
Okay, I hope she heard. And if you are still, you don't need to study alone. I know it can be challenging if you don't know anybody that is taking this course. If you check eLearn, the link to a WhatsApp group for this course is there. Check your eLearn platform. You just click it and you join so that you can interact with your colleagues. Also, if the messages I tried to send you earlier today eventually come, I also copy the link, and so you have it in your mail or in your module if it comes. I've sent it up to 4 times. I think network was bad or something. All right. Is that okay? So I'll call Florence Abiola. Unmute yourself. Florence. Your name Florence or Florence?
Florence, ma.
Florence. Florence. Okay.
Yes, ma. So good afternoon, ma.
Good afternoon.
And thanks for the
Can you go on? He muted himself. Okay. I'll call Abdusalam Aishat. Unmute yourself. Aishat Abdusalam.
Good afternoon, ma'am.
Yes, good afternoon, ma'am. I can hear you. Yes, we can hear you.
Thank you very much for the lecture, ma'am.
Thank you too.
Yes, ma'am. Please, how can I access the previous lecture that I was not able to attend?
Okay. If you check your eLearn platform, the link to the recording is there. So you can access it that way.
Okay, thank you.
All right, thank you too. I'll call Umar Abdullahi. Please unmute yourself. Umar Abdullahi.
Good afternoon, ma'am.
Good afternoon, sir.
Yes, I need more explanation on that uniformity because my
Theory of,
network was bad. Yes, the theory of uniformity because my network was bad when you were explaining about it.
okay, when your network is bad, you
Yes.
won't take us back because your network is bad. You can watch the videos later, maybe the class later. And
Okay, no problem.
you could also read on your own. Law of what did you call it? Law of uniformity.
Yes.
So for law of uniformity, what it claims is that, can you see it? That
Yes,
in
I can
nature,
see.
there are various, nature comprises of different parts, many parts, like we have in the universe. There are many parts in the universe. So within this system, everything, it happens according to rule. There is a certain order or harmony that is found there, which pertains to some regulation. So The law assumes that the universe, it doesn't change. Like there is some kind of constancy found in nature. So the laws governing its behavior, it's quite constant. It remains constant. That's what it means basically. But
Yes,
just
thank
as
you.
I said, the recording of this session will be on your e-learn, so you can visit it and interact with it as much as you want. Is that okay?
Thank you.
So I'll stop sharing. So I'll call. Please mute yourself when you're done talking. Johnson Samuel Akpan, unmute yourself. Johnson Samuel Akpan, are you there?
Yes.
All right, so we're listening to you.
Afternoon.
Good afternoon.
I want to ask.
Okay.
On some of these theories that you mentioned to these old philosophers that are known as scientists, some of their theories still count as fact. And the one on pills that says the source of all things is water, and few others, I'll still leave that counted as fact or theories, or if you are just learning it just for the history, just for us to get acquainted with the history of the course. I don't know if you understand
Say it again,
my question.
Your network was breaking.
Like I want to ask if some of the theories you explained to us. Like I would like to know if many of them are still counted as scientific facts. Like the one on that says the source of everything is water. And fears. I would like to know if they are still counted as scientific facts, or we are just learning them just to get acquainted with the course and the history of the course.
Thank you. That's a good question. You know, the heading under which we discussed it is origin of science. And we are looking at them as part of those who brought about the systematized science that we have now. You know, you and I, we belong to 21st century. If we use the eye of today to look at their postulations, their postulations will seem stupid. How on earth could you say that it was water or whatever? But they were making their postulations as far back as maybe 5th century BC and the likes. So it's not so much about it being scientific facts or whether it is still regarded as scientific facts, but the fact that they are being reckoned with as those who initiated what we now know as science through the means they used and what they said. Remember, under Thales, who says that water is the substance from which the universe came from. Thales got that through by observing his environment. He observed his environment through the use of his senses. Okay, and observation, if you were in class or you've watched the video of last week, is one of the steps in scientific method. So we're explaining them as history, as those who initiated this very high science and technological age that we have now, that you cannot talk about history of science without making recourse to things they have said that over the centuries, philosophers, scientists keep building up to give us what we have now at this present age. I don't know if you understand what I just explained. You know, they will say to understand the future, you have to understand history. So we're talking about how science originated. There is no how we can talk about the origin of science without talking about those people. More so if we know that science is a breakaway from philosophy. So that's the sense in which we're making reference to it. Is that okay? Can we move on? Okay, so I'm going to call Precious to unmute. Precious, unmute yourself and speak.
Good afternoon.
Good afternoon.
I wasn't around where you were speaking on how scientific work.
Come again.
How scientific work, how science work in the real life, sorry. How science work in the real life.
I don't get
I
that.
didn't get something there. Ma, can you hear me?
Yes, but speak up. I don't get your question.
I said I wasn't there when you were speaking about how science work in real life.
How did we say anything like that? How does science work in real life?
Yeah, I think so. Yes.
I don't get that.
Yeah, but let me just ask you a question.
So what's your question?
Yeah, my question is still on theories. My question is still on theories, and the question goes like this: if theories were already tested and
The theories what?
if theories have already been tested and they have been concluded on, if another suggestion came up about the theory again, how do we relate and balance it together?
That was what we discussed last week. When a theory comes, the old theory does not become bad or incorrect. It simply becomes obsolete. Because just as we explained last week, theories are tentative. They are not cast in stone.
Okay.
A newer one, having gone through the same process, would come and displace the old one. So when it displaces it, it doesn't make the old theory false or incorrect. It only makes it to be obsolete. It makes it old. It's an older form of theory. That's what we're saying. But that question doesn't pertain to this class. It was last week's question. But is that okay?
Yes, and I want to also ask about the TMA because I was checking.
About what?
TMA. No
okay.
Question
okay. Okay, it was asked at the TMA.
No, the question I know that I was trying to check the TMA. No question was
No question was given to you.
Yes.
I've addressed that. If you're not seeing,
even up to now.
If you're not seeing question in your TMA, please consult your study center. Ask them question there. What the problem is, they will be able to guide you. And if you have friends who had done their TMA, ask them. Maybe there's something they did differently. And I also think that if you newly registered, you can't expect to see your TMA. No. Maybe you registered only 3 days ago or something. So there are lots of factors that could make your TMA not to appear. They begin by asking at your study center, the help desk there, or asking colleagues what the problem could be. But I just gave you one or two what the problem could be. Is that okay? All right. I'll call Ola. The person's name is simply Ola. I'll call the person. Unmute yourself if you're there. Good afternoon.
Thanks for the lecture.
Thank you.
I want to ask, according to Charles Darwin, the evolution, can we say the man is an atheist?
Well, I don't know whether he was an atheist or not. I don't know, but that's what he thinks. That's what he thinks. I don't know, but it will not be strange if he's an atheist.
Okay, because the question came out in my TMA.
Okay.
Yeah, it came out in my TMA. That was why I want to confirm it from you.
Whether he's an atheist. I don't know if he's an atheist. I don't know if it's written in your text that he's an atheist. So maybe you read that portion portions that have to do with Darwin and find answers.
All right, thank you.
Okay, thank you, sir. Adeyi Sunday. Unmute yourself. Adeyi Sunday.
Yeah, good afternoon.
Good afternoon.
Yes, I have a question from the TMA.
Please note that I don't know the questions you were given in your TMA. So I might not be a right person to ask that question. I don't know the questions that were given to you, for example. I don't know. I'm not familiar with it. Just I explained it earlier. Maybe I said 150 questions.
Okay.
That's the way it works. Is the facilitator sets question, gives it to the directorate in charge of exams and assessment. And so that directorate shuffles the question and give you 10 out of 150. So I'm not familiar with the questions that were given to you.
Okay, but what's making everything difficult for us is that the question like comprised of all the units. Like they pick the question for each of the units. So the work is so bulky for us. So the TMA is difficult, a kind of.
Well, I cannot help it. What I said earlier was skim your course material. Don't keep it the way some of us keep our Bible or Quran unread. Don't keep it and it becomes new. Skim. Skimming is you do fast reading and come for facilitation and listen. At least if you skim, some parts will be familiar to you. Some parts you will use idea. You will use sense. You don't quite get it, but I don't know if you get it. So don't keep it. Don't keep your course materials. Skim first. Do fast reading. Flip through. Get familiar. I cannot help it. I cannot.
Right. So
That's
I'll
why
have
you are
to.
student. So, and you also have exams to prepare for. You have 2 more TMAs. Do as I've said now. Skim everything. Come for class. Listen in class. Skim each of the unit. Just look, if you like, look at it like picture. There are pictures in your course material. Look at it, skim. Get familiar with the ideas. Somehow, some will stick. You come for some facilitation, some will stick. When you read, some will stick. Before you say Jack Robinson, everything has stopped. And during exam or TMA, there are some questions you will use your own natural idea or residual knowledge to answer. Thank you.
All right.
So I'll go ahead. Our time is fast spent, but I will just give maybe 10 minutes to 10 minutes extra because I'm seeing lots of hands now. So Esu Pascal Innocent, unmute yourself.
Good afternoon, ma.
Yes, good afternoon, sir.
Yes, thank you for your facilitation. I'm impressed. While I was going through the course material and I read about Charles Darwin's theory, I've been contemplating on how I could link that particular theory to real life. So I want you to help and offer a real life example of Darwin's theory, nature selecting the fit and rejecting the unfit. You see, I've been contemplating on this thing, so I really want you to help and give a real life example.
Okay, real life example of natural selection.
Yes, natural selection. Yes.
The example that is coming to my mind is example that pertains to reproduction.
Okay.
You know, they say millions of sperms are released and only 1 or 2 gets fertilized, so to speak.
Okay.
It's I would think that The one who gets fertilized or the one who made it to the finish line, it's not it's by some kind of natural selection that comes about.
Okay.
How that's the example that comes to mind. But when we also talk about natural selection, we could think of it in terms of okay, maybe that's all I have to say on that. Maybe next week, if you ask me, I would have looked for more examples on that. But that's what comes to mind readily regarding that's explanation on natural selections in nature, right?
Yeah.
Natural selection in nature. That's what comes to mind readily now. So if I
Okay, ma.
remember, I could look up some more examples on theory of natural selection.
Okay, ma. Thank you very much.
Or do you have any you want to share with us?
For now, let me just give chance to my fellow colleague, my classmates, so that they could also ask their questions. Maybe next class, I will discuss on that.
Thank you. So it's past 4. I'm going to give numbers to the 5 hands I'm seeing up so that we can end this class. What I've discovered is question will begin to birth question and question like that, and we will go and it will be endless. So I'm seeing 5 hands up, and I'm going to give each of them number. Dave is number 1. Doshima Adam is number 2. Moses, please note your number. Moses Emmanuel is number 3. Is number 5. So I'm going to take those 5. I'll take those 5. So, Dave, I'm asking you to unmute. Unmute yourself.
Hello, good evening, ma'am.
Yes, good evening, sir.
I want to ask about this Thales, how do you say, all water is the source of all things. Can you throw more light on that? Why did he say so?
Did you begin this class with us?
Yes.
Were you paying attention? No. You were not paying attention. Let me just ask you. Those who are from riverine area here.
Yeah.
Maybe from Bayelsa, have you? Port Harcourt, those who are Ijaw, right?
Yes.
Where they are surrounded by water. Maybe they use canoe to get to their houses. You get. So
yes.
Imagine that Thales came from an environment such as that. And so year in, year out, is mostly surrounded by water. And you now ask him, so tell us, Mr. Thales. And from that water, he cooks, he drinks, he gets his fish, right? And we say water is life. And he experiences it firsthand, being a man from riverine area. What would you think he would think is that which the universe is composed of? He would naturally think it's water. So from observation, Thales, from looking, surveying his environment, thinks that it is water that is the constituent of the universe.
Okay, I've gotten that one now. And then the second one.
Okay.
According to Darwin, that we are evolved from apes. And then why are we having this slight different? Why are the apes not behaving like we humans, and we humans were not behaving like the apes?
Okay. In this present class, we have not discussed that. We only touched on it based on somebody's question. So reserve comments till the day we come to class, till the day our discussion in class pertains to that aspect of Darwin itself, then we'll take
Yes.
it. Is that
Okay,
okay?
it's all right. All right, thank you very much.
Thank you. Lower your hands. So I'll call who is number 2. Who is number 2? Okay. I'll call Freedom Titus. Unmute yourself.
Good afternoon.
Good afternoon.
Okay.
We can hear you.
Is going through loss of nature.
Speak up, or speak up.
My question is going through loss of nature. Loss of nature.
I can't hear you.
Okay, my question is going through loss of nature.
Loss of nature, okay.
So I did not when you were explaining that my network was very busy back then. So when the team connected again, we have already passed here. So I didn't understand it.
Okay, we're saying that what we call laws of nature or natural law, they are so called because they are quite global, and having been tested and known that it is universally accepted, that's why we refer to them as laws of nature. So they are not civil law, they are not criminal law or anything. But having gone through several repetition, validity, universally accepted and known, that's why we refer to them as law of nature or laws of nature or natural law. So you could read more on that in your course material, or you go through this video again. I'll post the link in our course e-learn platform. Is that okay?
How will I go?
E-learn, through e-learn. You don't know e-learn? Through e-learn platform, you will see the link there. All right. So, okay, we've taken 2. The next person, did I call? Okay. Doshima, unmute yourself. Unmute yourself. Adem Doshima, unmute yourself. I can hear you.
Hello, ma'am.
Yes, yes.
Good afternoon.
Good afternoon.
Thank you for the facilitation, the aspect of tally. The part where the tally also forecast the exit of. For the exit of 525 people, what does that really get at point there?
I didn't get what you said.
The 525 people, is it like?
The network is not good though. I can't hear you. Can you chat it to me? Chat it. Put it in the chat box. So who is remaining now? Pius Anehe, I never called you. Our time is gone. Did I call this Onimisi before? I don't know. Okay, I think I'm done with the persons I called, 5 of them. So that we don't extend this class beyond necessary. No. Okay, I'll just call this Moses Emmanuel. It will be the last person. So unmute yourself. Moses Emmanuel, unmute yourself.
Yeah, good afternoon, ma.
Good afternoon.
Yeah, thanks for today's lecture, ma.
Thank you too.
Yeah, during the study of my course materials, I come across scientific hypothesis. This, ma, can you shed more light on it, ma?
Scientific hypothesis we discussed last week, Abby?
Yeah, this is my first time of joining the lecture, ma.
So it would be good you look through the link of last week and read about it.
All right.
Yes,
All right,
this
ma.
is the second week of lecture.
All right,
Now,
ma.
what
And my second question, ma.
What scientific hypothesis means? Hypothesis, simply put, is guess. Guess, like a smart guess, a wild goose guess, so to speak. You form hypothesis, which you would experiment, you perform experimentation on. After which, when you've done experimentation, you move beyond the realm of hypothesis and it becomes a theory if it's passed. That's what it means basically. The details on that you could get more in maybe when you look at when you watch the link of the class for last week. All right. So hypothesis itself is one of the steps, like the first step in formulation of hypothesis in scientific method, or all other methods come. So your second question.
Right, yeah, when a scientific theory is being changed to law of nature, can it be easily changed, ma?
It becomes it over time. When it's held sway, when it's kind of universally accepted, it becomes, it's adjudged to be law of nature at some point in time. And it takes a long period of time. Yeah.
All right, ma. Thank you, ma.
Okay. All right, so we've come to the end of today's class. The class is meant to be 3 to 4 days, 17 minutes past. So one thing I observed, you didn't respond to the question in the chat room. That's on your e-learn. You didn't respond to the question, but it's one of the avenues provided by the management to have you interact. You know, we could not take all the questions in class. So if I ask you a question in the chat box and people respond, you read other people's comments. After some time, I also make comments and submissions. It's one of the ways to concretize your learning. So if you've not done so, as many of you did not, it's only about 1 or 2 persons. Please go to the chat room on your e-learn and respond to the questions so that we could have discussions beyond 1 hour that we have in class, okay? So as we normally do, I'm going to unmute everybody as we exit the class. So you are even unmuting yourself already. So you can. I thought you could not. So it's okay.
Thank you, ma.
Just call to unmute, yes.
Thank
So,
you, ma. All right. Thank
you
so much, ma.
Thank you, ma.
Thank you, ma. Have a nice day.
Thank you.
Thank you, ma. God bless you, ma.
If you have any pressing questions,
God bless you, ma.
send me an email. You have my email address.
Class. Right.
Thanks, can you drop your email address, please?
So send
Thank you very
on
much.
this address I'm sending to you.
Thank you, ma.
Whatever questions you have, try and
God
answer
bless
it.
you, ma.
Bless you. Nice day.
Thank you. Bye-bye.
You're welcome. Thank you.
Thank you, ma.
Thank you, ma.
Is there anyone from Ikorodu here? Please, so if you are from Ikorodu,
I'm from Ikorodu. Thank you, ma.
Ikorodu people,
Thank you.
let's meet, let's know ourselves. So.
Have a nice weekend.
Bye. Anyone from
I'm ending the
Ilari?
class now.
Bye. Bye. Thank you, ma. Thank you.